Hi everyone, in this video we're discussing 10 pet interview questions that I've personally been asked in the past 3 years, either working as a full-time employee in a remote company or while interviewing for a freelancing platform like Upwork, Gigster or Braintrust. These are both good opportunities for you to start working remotely and get hired in various companies from all around the world. And I've seen that the questions that they ask are usually much simpler than general FANG interviews. The questions are around the depth of your knowledge on technologies that you've worked on and the technologies that they need. And the questions that I'm discussing in this video are pet questions that I've seen they've asked me in interviews. All of these are full stack related. In fact, if you've gone through the full stack assignment part 1 and part 2, you should be able to answer all of these questions. They are slightly difficult than what we've discussed in these two videos, but if you've done a bunch of practice, written a bunch of websites in the MERN stack, you should be able to answer these with ease. Throughout the video, listen to the question, take a pause, try to answer it yourself, try to go to ChatGPT and get the answer, and then wait for my explanation. This way you'll chew some glass rather than binging through the video. With that, let's get right into the video. The first pet question, a very simple one, especially in a full stack interview, is the difference between let, const, and var. These are sort of ways for you to define variables in JavaScript, and JavaScript is the language that you'll be using in full stack development. Either you're using some other language for backend or JavaScript, but the front end will purely be in JavaScript. So this is like a pet question that you should know the answer for. So the difference between them is that let and const, firstly, like what are these? Well, there are ways for you to create variables. If I click on inspect here and if I type where a equal to 1, I have a variable here that has the value 1. If I set a equal to 2, it now has the new value 2. Very similar to how do you define these in C++, like int a equal to 1, something like that, I think. So similar to that, they have a generic type, so you don't have to provide the type right here when you're creating the variable. It could be a number, it could be a string, but there are 3 different ways to define them. As you can probably guess from the name, const is a constant. So if I set const u equal to 1, if I try to change the value of u now, the value is currently 1. If I set u equal to 2, it will throw an error and it says you can't assign to a constant variable. And similarly, if I simply do let x equal to, or maybe y equal to 2, I can actually change its value, and then when I do, the new value is printed whenever I am printing the value of y. The more important question here is why even introduce let when where is already there. There are a bunch of differences. The most important one is if you define a variable, let's say ASD, inside the scope of a block, it can actually be accessed outside the block as well. That's not the case for lets. So if I do a let dd equal to 1 to 3 and I try to access dd outside, it will throw an error. So where and const are alive only during the scope of the block that they're defined in. What's a block? Well, whenever you have 2 curly braces and you define anything, any code inside, the scope of the variable remains inside as long as you're using let or const. But if you use var here, it can be accessed outside as well. Why was this introduced? Well, you probably don't want to use a variable that's defined inside a block outside that block. So that way, using let and const, you can be sure that you'll get an actual error during runtime. Versus if you're using var, it might just work for you right now, but might cause bigger issues in the future, which is why let and const is what's used inside the industry. If you have a constant variable, use const. If you don't have a constant variable, use let. You can always use var, but whenever you're working in the industry, never will you ever see var again. People used to use it when I was in college, but ever since let and const were introduced, these are the only 2 types that you need to define a variable. Let's move to the second question. Is the following code segment valid? Look at this code segment, try to figure it out yourself, and I will now answer it. It is valid and it uses a property of JavaScript called hoisting. The property says, even if you declare the variable at the very end of a file, it will get hoisted to the very top. So here, as you can see, I've set the value of x, a variable that's not yet been defined, to 5. And then I'm doing something here. Let me just make this even simpler. X plus equal to 5, console.log x, and let me run this in the JS console. Especially in a language like C++ or Java, you can't really use a variable that's not yet been defined. But in JavaScript, if you're using var, it lets you do this. It basically hoists the variable to the very top. So this var definition gets hoisted, which is why if I now use x, it's pretty much present here. However, can I do this with let? Let's try that out. Let's change the value of var to let here, and then let's copy this whole thing and paste it. And it says identify, this is the wrong error because I'm reusing the console. Let me refresh. Now if I try to use let here, it won't let me because it says cannot access x before initialization. X is initialized here. You can't really access it on line 1 because it's initialized on line 4. This property of JavaScript is called hoisting. Again, you won't ever use it because you're not using var anymore. You're only using let and const, and this is another reason for you to use let and const versus vars. With that, let's move to the third question. This was a pet interview question that was asked in a very grueling interview to me. So I almost answered this incorrectly because there was like a lot of pressure during that interview. But then midway through my answer, I realized my original answer was wrong. But the actual answer is, if you look at this code segment, it's actually incorrect. And the reason for that is it might feel like this is a loop, but it sort of is a loop, but there's a big difference between writing a loop like this. So I've written another way to do the same thing that's being done here using a for loop. Here we're using array.forEach. Now the thing about for each is it's not exactly a for loop. In any language, usually when you're writing a for loop, you can break through the for loop and break outside the loop if some conditions are met. But if you look at the argument here, it's a function, and break isn't really valid inside a function. It's only valid inside a loop. So you can't really break out of this. If you're calling array.forEach, each and every of these will get called. If you want to sort of ignore them, you will have to write some other logic. For example, if I had to achieve this using for loop, I'll probably define a bool here by false, and then if this is the case, I'll set done equal to true, and then only if not done would I log the thing that I want to log. So this might be a way for you to do the same thing, only you're iterating over all the elements here. So if you want to break, you will probably have to use a for loop like this. If you're using for each, you cannot break through it. Break is actually completely invalid inside a for each because, well, it's not inside a for loop. With that, let's move to the fourth point. Is JavaScript single threaded, and can your browser only run a single thread? This is slightly related to operating systems, and there are multiple answers to this. The first simple, very basic answer is yes. JavaScript is single threaded. The way the language was written was it was single threaded. You can spawn out other processes from it, but JavaScript is running on a single thread. If you don't yet understand what I'm saying here, you might have to go through some concepts of operating systems. But from the very top, you might have heard of RAM, CPUs, GPUs, things like that. And so your machine has a bunch of what are called cores. And if you have, let's say, 20 cores in your machine, you can pretty much run like 20 processes at the same time. But the thing about JavaScript is the way the language was written was that it will only run on a single processor. If you're running a single JavaScript process, it can only use one processor. So it doesn't matter if you have a machine which has 20 cores or if a machine has one core, it will actually have the same performance as long as no other process is running. If there's only a single JavaScript process running on a machine with 20 cores and a machine with a single core, so it doesn't matter the size of your machine, it will perform the same because, well, it's single threaded. Now, can you make it multi-threaded? There are ways of doing it. There was a library that Microsoft introduced. Let me check. Microsoft multi-threaded JS. Napa.js is a multi-threaded JavaScript runtime. So people have tried to make it more performant, but usually what's common today is the JavaScript that runs inside the browser or a Node.js backend, both of which run on a single thread. Now, when you're running it on a backend on a very beefy machine, you probably want to make sure you're using all the resources of the beefy machine. So there are ways to run multiple instances of the same Node.js process. So if you have a single, let's say, Express server, for example, the Express server that I gave to people in the full stack assignment, this Express server, if you run node index.js, will run on a single processor or will use the resources of a single processor. But if I run the same process 20 times on a machine that has 20 cores, then it can be more performant as long as you can load balance the requests correctly. So that's the basic idea of how you can do multi-threading sort of. You can use all the cores of your machine. You can't really do multi-threading in JavaScript, but there are ways for you to run multiple processes on the backend. And even on the browser, there are ways for you to spawn more threads and delegate heavy processes to what are called as web workers. So your browser runs on a single thread, but if there is an expensive operation, for example, when you want to do machine learning inside the browser, or if you want to do video processing, like do a background reduction on Google Meet, all of these things happen inside a web worker, so that your main JavaScript thread, the main thread that's running the website, isn't overwhelmed by these expensive operations of taking background out, because that's a very expensive operation when you're trying to background reduce a video, especially in real time. So there are ways for you to use multiple threads inside a browser and on a backend, but the short and sweet answer of is JavaScript single threaded? The answer is yes. With that, let's move to the fifth point. What languages does your browser understand? I've answered this in the React assignment, and the answer is that it could only understand JavaScript, HTML, and CSS up until a very long time ago. But then they introduced something called as WebAssembly, which lets you basically run assembly code inside your browser. And any language, be it C, C++, C++, Rust can be converted into assembly code that now your browser can run. In fact, if you might have heard of a very popular video processing library called FFmpeg, may or may not have heard of it. VLC player is sort of built on top of it. It's a very complex piece of software that's not written in JavaScript, but now runs inside the browser, inside a web worker. So a lot of like websites that you might have seen where you put a YouTube video and it downloads it for you. A lot of times they're doing all the processing inside your browser, like merging the complete video, transcoding it inside your browser. And that can now be done because FFmpeg can run inside your browser. Why can it run inside your browser? The browser only understands HTML, JSON, and JavaScript. Well, now it can understand other languages as long as you've compiled them to assembly, and that's what you're running inside your browser. With that, we're done with the first 5 questions. Let's take a pause here. As I said, all 5 of these have been asked to me in an interview, and this is how I explain it. I basically tell them everything I know. For example, there's no right or wrong answer to whether JavaScript is single-threaded because, well, Microsoft released a framework that lets you do multi-threaded JavaScript. Also, the answer to is Node.js single-threaded. Well, it is single-threaded, but you can still use the power of your machine or of a very beefy machine as long as you're running multiple processes and load balancing all the requests to them. So there's no right or wrong answer. Always try to be as elaborate as possible. Make sure your fundamentals are right. Once your fundamentals are right and you tell them everything, they'll be super impressed because a lot of times the people that are interviewing are also like not that great. They understand things from the very top. So if you tell them something that even they don't know, they're usually pretty impressed, and it's a good way for you to get into these companies. Cool? ठीक है. If I was very fast, if you haven't seen these before, try to digest them, take a pause, go to ChatGPT, talk to it, have a break, go out, touch some grass, and then come back to the next 5 points. Because as I said, these are all very important and very pet questions. So you need to understand them from the very basics, not from the very top. You should understand everything because when the interview is happening, this is not a DSA interview. They don't want to see AC and move on. They want to make sure you understand everything, and you will only understand everything if you understand all the concepts that I've talked about here. So make sure you're able to digest everything that I've taught here before moving to the next 5 points. With that, let's move to the next 5 points. The next question is, what are middlewares in JavaScript? Now, this is actually a very vast concept. They're also called extractors. And this is not a JavaScript specific thing. These are used across languages. And middlewares, or generally the code that you see here, might feel a little confusing, but it's basically a way for you to pre-process a request that comes to your server. I've said a lot of things here, so let me repeat. Pre-processing a request, as I said in my first part of the full stack video. If you haven't seen that, first go there, check it out, and then come back. Servers accept HTTP requests. Whenever a request comes, you sort of need to process it, understand what's asked from the request. A lot of times your requests need to be authenticated. You need to make sure, if I'm going to notion.com right now, Notion needs to make sure if I ask for this block of text, let's say, that this is me, Harkirat, who's asking for it. And hence they need to sort of do some validation checks similar to what are being done here. This is one of the submissions of the full stack assignment by our friend, who is this? XR Zarcode. And as you can see, what they're doing here, every time there's a request to sign up, they extract the email, the password, and the type of the user, admin or a normal user. And then they find whether or not this user is already in our database. If they aren't, then they create a new user, push that user to the users array, and that's how your database or your backend sort of stores the user for now, and it returns the end user a 200 status and tells them a token, hey, a new user was added. A lot of this is dummy data because this was a simple assignment. So this is the generic way for you to handle requests on your backend. Now, as I said, sometimes the backend requests that are coming need to be authenticated. You need to make sure that the server that's trying to hit this specific endpoint sending a post request is already logged in. So what you do, you introduce these things called middlewares, which effectively are functions only, which do some magic on the request and they try to extract some data from it. Usually it looks something like this. There's usually an auth middleware, and the job of the auth middleware is to make sure. So the thing that you see here is effectively chaining. Your initial request will go to this auth function. After it goes to the auth function, as long as the auth function says that the authentication is right for this request, then you move to the admin function. So these are functions which might look like variables. I'll just define them below so that it's easy to understand. The second middleware here checks whether or not this user that was extracted here is an admin of the website. So what we were creating here in the assignment was LeetCode. LeetCode has admins that can create problems. So the second middleware that I've defined here again, this can be different for different use cases. When the user is signing up, you don't need any middlewares. But when the user is, let's say, creating a new problem, you need two middlewares. You need to make sure that the person who's hitting the endpoint is authenticated, which means they're logged in and they are an admin. Only if these two conditions are met do you move to this third code block where you actually update the problem or add a new problem. So effectively, auth and admin are both functions that take in a request as an input. So as you can see, the third function takes rec and res as input, which is like request and response. This guy also takes rec res as input. It also takes something called a next as input, which you don't have to worry about right now. Worry about just the request. It'll sort of extract the cookie from this request somehow, and then check in your database whether or not this is a valid user, or like const user name equal to check cookie. So it'll check the cookie. If the username exists, only then will it, let's say, return true. Else it'll return false. So this function, the auth function, the first thing that gets called when the / project endpoint is hit, then you call the auth function. The auth function checks whether or not the user's request contains a cookie which maps to a user in our database. If it does, only then it returns true. If it returns true, the control then reaches the admin function. What do you have to do in the admin function? You have to check const is admin equal to rec.username, maybe call is admin function, which hits your database to check whether or not this username is an admin. If it is an admin, return true. Else return false. So now we have defined two functions which are called middlewares or extractors, which extract data from your request, and only if they succeed do you move the control to the next function. Why even do this? Like, you could totally do this here at the top of this function. First extract the cookie, and then you don't need return true or false, just return here and return here. So you could do it here as well inside the / project function, like these middlewares, and then do everything here. The problem is you might have to do it in multiple places. There might be another route that does a get on, let's say, some admin data. So if you don't do it the way I've done it here, where you extract these middlewares out, you'll basically have to rewrite this logic here, which is sort of ugly. You could also like say, why not encapsulate this logic into like a single function? And just call the function here before going through all the logic. This is true. You could do that. You could just have a function defined that could sort of be called here versus calling the middlewares here. But the sort of worrisome thing there, which isn't really worrisome, but your control is sort of reaching this function, which you don't want. Like, if the user is unauthenticated, why even run this logic at all? Which, well, it wouldn't if you call the function here, but it's just a cleaner way for you to chain various middlewares together. You could actually do them here as well. This is the way it's usually done, where any request that's coming, before it reaches the actual handler of the request, it goes through a bunch of middlewares based on what kind of authentication you need. And that's the whole concept behind a middleware. Hopefully that was clear. I do remember seeing a bunch of people creating middlewares in the assignment, and the people who did, great. That's sort of, you're like intermediate level to mediocre level to almost advanced of a developer if you understand middlewares, because that's what most of backend is, right? Writing a bunch of routes, and then middlewares are like a cleaner way to write those routes. Cool. With that, let's move to the 7th point. Have you written backend systems in your previous job? How do they talk to each other? Are they synchronous or asynchronous? This is a question that was asked to me by an Indian company that I got an interview for through a freelancing platform. They were basically asking me about my experience. I told them about Goldman, and they said, did you have backend systems there? I said, yes. Then they asked, how did they talk to each other? This, again, I've explained in the first part of the full stack video, where backend systems need to talk to each other, sometimes synchronously through HTTP calls, or sometimes asynchronously through message buses or RabbitMQ or Kafka. Things like these, which are asynchronous requests that you don't need to process just yet, can happen slowly and steadily. So go back to that video. I've spent like a good 5 to 10 minutes explaining it there. And if you don't still understand it, let me know. But with that, let's move to the 8th point, which is, have you ever containerized apps? What is Docker and why do you need it? So this is again a very important thing that we'll probably do in the 4th or the 5th part of the full stack assignment. Any backend that you write, and sometimes frontends, but mostly backends, any backend that you write is a Rust code or a Golang code or a Node.js code that is effectively compiled into some binary, or sometimes in case of JavaScript just into like a bundled JavaScript. You have these files, these binaries that you can now run anywhere on a machine. usually on AWS, GCP. So you write your code, you push it to GitHub. From GitHub, it reaches AWS like a bunch of your machines and it runs there. The problem is you might need a bunch of frameworks, right? For example, if you're building a Node.js app, you need Node.js installed, you need NPM installed, you need NVM installed, things that we did in the first part of the full stack series. But your machine that comes up, the machine that comes up on AWS, especially if you're running a very big system of like 1,000 machines, every time it comes up, it's like a basic Ubuntu machine, which has no dependencies. It has no Node, no NPM. So what you can do is, what if you could define the machine? What if you could say, hey, I don't want an Ubuntu machine. I want a very small part of an Ubuntu machine because, well, Ubuntu has like a bunch of things which I don't need. My app only needs Node.js. My app only needs NPM. Hence, give me a very small machine, which looks something like this. It has NPM installed, Node installed, and has this code of mine which can run and has maybe a bunch of secrets and environment variables, and that's it. What if you could write all of this down into a spec, into a file, and then create these things called images, which effectively are like, if you've seen ISO files when you're trying to install Ubuntu on your machine, it's effectively like an image which you can run anywhere, and it'll be like a container of its own or like a mini machine that runs inside your big machine, which has all the dependencies that you need. And why is it useful? It's useful because now you don't have to install Node.js on every nascent machine. You just have to tell that machine, hey, run this Docker container, and that Docker container, that small image that I just discussed, effectively has all your dependencies. So it's like a very good way for you to define images that has your code, that has all the dependencies. Then you can just throw them on various machines. So that's sort of why Docker and containerization is used. There are a lot of concepts here that I'm missing. DevOps in itself is a very big field. It's just the gist of understanding how containerization works, why containerization is needed, and how Docker helps you achieve that. If you need a longer video on this, let me know. This is like a 5-hour video on DevOps and how you can deploy apps in production and why you shouldn't use nascent machines and why Dockerization or containerization came into the picture. With that, let's move to the 9th point. What is state in React and how is it different from normal variables? I have explained this in the second part of the full stack series, so I'm not going to explain it again. You can just check out that video at this timestamp. But from the very top, state variables are variables that your React runtime is sort of looking at and making sure anytime your state variables changes, it re-renders the components that have now changed. This is the textbook answer that you can give, which will work. But if someone actually starts to ask you why that was introduced, why do you need state, why not use random variables, why doesn't React look at random variables, why does it only look at state, then you need to check out the second video where I've explained this in detail. With that, let's move to the 10th question. What is the virtual DOM and how is it different from the DOM? There are actually two questions here. What is a DOM? Explained in the second video. Go check it out there. What is virtual DOM? Not explained in the second video, probably will come in the third video, but left here as an assignment. Tweet at me, tell me what virtual DOM is and tag me on Twitter and I will tell you whether or not you were right. Don't ChatGPT it. Make sure you understand it very well. It's like a very important concept in React. It's how React becomes so performant. So understand DOM, understand virtual DOM. And these are two very important pet questions that people ask because these sort of represent your depth of knowledge in front-end development. So you basically need to know this probably before even you start writing React code, because it's very easy to write very complex React code and not understand how React does things under the hood. Virtual DOM is a very nice concept that if you understand it, you will actually understand how React sort of is used in native applications as well, not just like to create browser applications. You can create native applications, you can create TV applications, like a bunch of these things. And the virtual DOM is sort of the crux of how it's able to do it. Understand this much. VDOMs and virtual DOMs and the actual DOM are like a good thing for you to know, and a very pet interview question as well. In that, we've completed 10 points. One bonus question here is a lot of times these remote companies want you to do some actual work before you join. So they might give you an assignment that's very close to their product. So if you're joining, let's say, an education company, they might be facing a challenge right now. For example, in a live class, a lot of people start spamming their chat. How do you fix that? So they might give you an assignment like this. So you actually have to write code and interact with their systems. I've done this twice in 2 of my jobs. And these happen because, well, you want to make sure people don't have just theoretical knowledge. They can actually code, and an assignment like this helps you there. So make sure whatever company you're interviewing for, you understand their website and are able to solve complicated problems there. Again, these are like 4 or 5 hour assignments that you can do at your own time. And this is also a very important pattern that I've seen when you're interviewing for remote companies, because they want you to do some work before they actually give you a green signal. Cool. With that, hopefully this was a helpful video. I might be coming out with more such videos around project ideas to do questions that are asked and everything related to remote work. If you're looking for that, do subscribe. I'll see you guys in the next one. Bye.